Hello student, I hope you are doing good. In today's session, we're gonna cover one such paper of JEE Main session 2. I'll be covering the 2nd April paper, that too of evening shift. So, the first physics question that came into your examination is this assertion based question. It says, net dipole moment of a polar linear isotropic dielectric substance is not zero even in the absence of electric field. And the reason says, in absence of an external electric field, the different permanent dipoles of the polar dielectric substance are oriented in the random direction. So as you can see, the assertion, it says the net dipole moment of a polar isotropic molecule without external electric field um, is not zero, although it is always zero because the net dipole moment because of all the atoms is zero. So that means the assertion is not true, and the reason is quite true because it says that in the absence of electric field, the different permanent dipoles of a polar dielectric substance are oriented in random direction. That means if it is oriented in random direction, then the net dipole moment would be zero. So that means your reason is correct. So the option would be, the third option, A is correct, but reason is incorrect. Reason is correct and assertion is not correct. Next, the two plane large parallel plate conducting plate are kept 10 centimeter apart as shown in the figure. The potential difference between them is V volt. The potential difference between the point A and B is. So you have been given these two plate and the separation between them, let it be D, which is already given to you as 10 centimeter. Okay. Now what is the potential difference between A and B? Okay, and the potential difference across these plate is V. We already know that if electric field exists within this plate, this E dot D must be equal to V, the potential difference between the two plates, and the distance between them is D. Okay, the potential at A and C would be same, so that means the potential at A and C, potential difference across A and C, A and B would be same as that of potential difference across C and B. Okay, so we can easily write it down for this, from the potential difference across C and B, let it be V dash, and the electric field also exists, and the same electric field exists between them, and the difference between these 2 points are, if it is 5, this is 3, so this would be 4. Okay, and this D distance is your 10. Potential difference across C and B, let it be V dash. So divide it, E will gonna cancel out. So you'll get 10 by 4 is equal to V by V dash, and V dash comes out to be 4 by 10 V. Okay, so which is 2 to the 4 and 2 5, that means 2V by 5. So the third option is the correct option that we are getting. Okay, next. Energy released when two deuteron fuse to form a helium nucleus is what would be the energy release that you need to find out. The binding energy per nucleons of this deuteron and the binding energy per nucleons of this helium is already given to you as. So we're gonna write down the equation. Two helium atom combined to form two deuteron atom combined to form helium. Okay, you need to find out the energy released. Binding energy per nucleons of deuteron is 1.1. So here you have two deuterons. So the binding, so the energy, this binding energy would be equivalent to twice into 1.1 mega electron volt. So binding energy of this helium would be equal to, which is already given to you as per nucleons, it is 7. So how many nucleons is there? 4. 4 into 7, which is 28 mega electron volt. Remind you here the nucleons would be 4. 2 atoms, and each nucleons, each atom would have 2 nucleons. So in totality, the total number of nucleons is 4. So here it would be multiplied by 4. So it is equivalent to 4.4 mega electron volt. Here it is 28 mega electron volt. How much energy will be released? 28 mega electron volt minus 4.4 mega electron volt. So the answer comes out to be your first, which is 23.6 mega electron volt. Okay. Next, the moment of inertia of a circular ring of mass m and diameter are about a tangential axis. Tangential axis lying in the plane of the ring is. So you have been given a ring. You need to find out the moment of inertia along this axis, along the which is the axis lying in the plane of the ring is. Okay, tangential plane. First of all, you need to find out the moment of inertia along which is passing through the center of mass. Moment of inertia along this plane, which is perpendicular to the plane containing the circular ring, is mr square. Okay, so using the perpendicular axis theorem, you can easily calculate the moment of inertia along the plane perpendicular along the plane parallel to this ring and passing through the center of mass, which is mr square by 2. It would be half of this mr square. Okay, so you need to shift this, where r is the radius of this ring, m is the mass of this ring. You have to shift this moment of inertia over here. So the moment of inertia along this would be equal to mr square by 2 plus total mass into the shifting distance, which is r square. Okay, so it would be equivalent to 3 mr square by 2. Remind you here, we have taken as this as radius. You have to calculate it in the terms of diameter. This is, so r is the small r is the diameter. So this diameter is by 2 is nothing but your radius. Okay, so the radius comes out to be r by 2. So this would be equivalent to 3m by 2. Radius in the terms of diameter is r by 2 whole square. So this comes out to be 3m r square by 8. So the answer comes out to be your first one, 3 by 8 mr square. Okay. Next, consider a circular loop that is uniformly charged and has a radius of a root 2. Find the position along the positive z-axis of the Cartesian coordinate system where electric field is maximum if the ring was assumed to be placed in the xy plane. So you have been given this xy plane in which this ring is there, and along the z-axis at certain distance of the uniformly charged has a radius of, this radius is a root 2. Okay, consider a circular loop having radius. So along the Cartesian coordinate, where along the Cartesian coordinate along the z-axis, the electric field would be maximum. So this electric field over here would be the axial point because of this current carrying loop. So at an axial point, the maximum value of the maximum value of electric field can be calculated using the relationship. This distance x is nothing but r by root 2, that we already know. Okay, so at a distance of x is equal to r by root 2, the electric field would be maximum. Okay, so we can easily put this and we can calculate the distance. This distance must be equal to, radius is already given to you as a root 2. So root 2 will gonna cancel out. You will get the answer as a. So this would be the first answer that you must get. Okay. Next, 2 water drops each of radius r coalesce to form a bigger drop. If T is the surface tension, then the surface energy released in this process is. You have been given 2 drops, identical drops, forms a bigger drop, let its radius be r. So the volume of these two would be same, twice of 4 by 3 pi r cube must be equal to 4 by 3 pi r cube, 4 by 3, and pi will gonna cancel out. So r comes out to be 2 by 1/3 r. This is the relationship that we are getting now. The total energy of this minus total energy of this. surface energy of this minus this would be the release of energy. So the total energy of these two water droplet would be equivalent to surface tension multiplied by the total surface area, which is twice of 4 pi r square. So this is the total energy minus the surface energy of the bigger drop, which is surface tension multiplied by surface area, which is 4 pi r square. So this much of energy will be released. So we're gonna put the value. What we can take here as first of all we're gonna put the value 2 into 4 pi r square minus s 4 pi. We're gonna put the value of capital R square, which is r square is nothing but 2 by 3 into r square. Okay, we're gonna put this value 2 by 3 r square. Okay, so what we can take common is 4 pi r square into s, where s I have taken as surface tension. So it would be 4 pi r square into s. So here you'll get 2 minus 2 raised to power 2 by 3. So this is the final answer that we are getting, which is your second option, because surface tension I have taken as s. Okay, so second would be the correct option. Next, a body of mass 1 kg suspended with the help of two strings making angle as shown in the figure. Magnitude of tension T1 and T2 is. This weight would be balanced by the component T1 sin 60 component of this wire, and this is T2 sin 30. Here it would be T2 cos 30. Here it would be T1 cos 60. Since this block is in equilibrium conditions, so that means if we'll resolve these two vectors, so these two will gonna balance its weight and these two will gonna cancel out each other. Okay, so that means T1 cos 60. Okay, so this T1 comes out to be 2 will gonna cancel out. T1 is root 3 times of T2. So this is the relation that we are getting. Second equation is T1 sin 60 plus T2 sin 30 will balance the weight. Weight is m into g. Mass of the block is 1. So 1 into 10, which is 10 Newton. Okay, so T1 sin 60 is root 3 by 2 plus T2 sin 30 is half is equal to 10. What we can do is we can put the value of T1 from this equation. It would be root 3 times T2. So T1 can be replaced as root 3 under root 3 T2. Okay, root 3 will gonna multiply, so it will be 3 by 2. 3 by 2 T2 plus T2 by 2 is equal to 10. Okay, so 2 will go over there. So you have, or you can take the LCM. So of this, it would be 3 plus 1, which is 4 T2 is equal to 10. 2 to the 4 and 2 5 the T2 comes out to be 5 Newton. Okay, so which option is correct? Either fourth or either first. Now what would be, we have T2, so what would be T1? T1 would be root 3 times of T2, which is 5, so 5 root 3. So that means first is the correct option that you must get. Next, if mu naught and epsilon naught are the permittivity and permeability of a free space, then the dimension of 1 by mu naught epsilon naught is, we already know speed of light is given by relationship which is given by this mu naught epsilon naught. Squaring both the sides, you'll get c square is equal to 1 upon mu naught epsilon naught. So its dimension would be equivalent to c square, which is lt minus 1 raised to power 2, which is L square T minus 2. So second would be the correct option that you must get. Next, what would be the, you have to match the quantities in list 1 to list 2. Heat capacity have the unit. We already know heat capacity have unit joule per Kelvin. Okay, so A would be second. So either this one or, okay, only this one, because first it is the only option in which is written is matched with second. Okay, so the first option would be the correct option that you must get. Rest also, the specific heat would have dimension of joule per kg per Kelvin, latent heat joule per kg, and thermal conductivity would have this one. Okay. Next, a biconvex lens have radius of curvature of both the surface same as 1/6 centimeter. So okay, if the lens is required to be replaced by another convex lens having different radius of curvature on both the side where R1 is not equal to R2 without any change in the lens power, then possible combination of R1 and R2 would be. So if the power doesn't change, suppose initial curvature of the lens was R and R both are equal. So the power of this lens would be 1 upon F is equal to, let the refractive index of this glass would be mu minus 1, 1 upon R. R1 is plus R and R2 is minus R1, 1 upon R1 minus 1 upon R2. R2 is minus of R. Okay, so this comes out to be mu minus 1, which is minus minus plus 2 by R that we are getting. Okay, so this is the initial power. If you'll replace this lens with another lens which is having R1 and R2 as their curvature, so the power would be same. So it would be equivalent to 1 upon F, which is mu minus 1, 1 upon R1 minus 1 upon minus of R2. Minus minus would be plus. So since these two are equal, so mu minus 1, 2 by R is equal to mu minus 1 plus 1 upon R2. These two will gonna cancel out. Radius of curvature is 1/6. So 1/6 will go over there. We'll get 12 is equal to 1 upon R1 plus 1 upon R2. So from the equation 1 upon R1 plus 1 upon R2 must be equal to 12. So we're gonna check it then. If R1 is 1 upon 5, so 1 upon 5, so that means 5, or here it is 1/7, R2 would be 1/7, so it would be 7 plus 5, which is 12. So that means your first option is the only option that we are getting is the correct option. Rest in other cases, we are not getting this as 12. Okay. Next, given a charge Q, the current I and permeability mu naught, which of the following quantity has the dimension of momentum? First of all, you have to check it. You just put the value of dimension of Q, Q naught and I one by one and check whether you are getting the dimension of momentum or not. Okay, so you have to do this questions by checking the dimension only. By checking each dimension, you will come to know that the dimension which is matching with the momentum is the third one. Okay, there is no other way through which you can do this question. Apart from that, even if you know the dimension, even if you know the formulas, you have to just scramble that particular formula in order to get into this equation if you know the formulas. Okay, otherwise what you can do is just put the values of dimension and one by one check it and you'll get the third option as the correct option. Okay, next, in the diagram circuit shown in the figure of the given input, the P and Q value are. Here one is feeded, it will go over here. One is also go over here. From here, this is NOT gate, so 0 will be feeded over here. Again, 0 will be feeded over here. We're gonna move forward then. It is a NAND gate, so 1 1. In the AND, it is, since it is a NAND gate, so it would be 0. From here 0 goes and it becomes 1 over here. Here it is OR gate. 0 0 is again it is equivalent to 0. 0 will go over here and it will come over here. Okay. Now 0 0. Then this is again AND gate. 0 0 comes out to be 0. Here it is NOR gate. 1 0 1 0 must be equal to 0 since it is an NOR gate. Okay. So 1 0 input would have 0 output. So the final answer that we are getting is 0 0. So the third option is the correct option that we are getting. Next, sportsmen run around a circular track of radius r such that such that he traverse the path a b. The distance traveled and the displacement would be. He goes from a to b, again from a to b. So that means a to b, again from a to b. Again it goes to a, again it goes to b. So that means this is the initial point and this is the final point. So the displacement would be twice of r. Okay. So which option is correct? The first option is the only option that we are getting, where the displacement is twice of r. Okay. And the distance again would be 1.5 revolution of 2 pi r, which is 3 pi r. Okay. So the first option is the correct option. Next, an electron with a mass m with an initial velocity is v0, which is along x-axis, enters a magnetic field which is along y-axis, which is v0. If the initial de Broglie wavelength at t is equal to 0 is lambda naught, then its value after certain time t. Obviously, so you have been given a electron in which the magnetic field is acting along the y-axis, which is b0, and it enters this magnetic field with the velocity v0 along the x-axis. Okay, again it will experience force since this velocity is perpendicular to this magnetic field. So it will experience force, and that force would be perpendicular to the motion of this electron. Okay, so that means the velocity will not change. The speed will not change. It will go on a circular track. It will keep on moving on a circular track. Okay, it will keep on moving on a circular track, and the velocity the speed won't change. If speed is not changing, so that means your speed is not changing. So initially it would have in the initial de Broglie wavelength is lambda naught, and this wavelength lambda naught could be written as h by mv. Okay, it depends on the velocity. Mass of electron does not change, and speed is also not changing. So that means after a certain time it would have, and again it would have same de Broglie wavelength. Okay, so the option would be the fourth option. Next, solenoid having area A and length L is filled with material having relative permeability. Mu r is given to you as 2. So you have solenoid which is having area A and mu r is 2. Magnetic energy stored in the solenoid is. Magnetic energy stored per unit volume is given by half. Energy stored per unit volume is given by half mu into b square, where b is the magnetic field which is there inside this solenoid, and mu is the permeability of the medium. Okay, so this mu comes out to be mu naught into mu r. So mu is equal to mu r is twice of mu naught. So mu r is 2, it would be equal to 2 mu naught. So energy stored in it would be equal to half by mu is twice of mu naught b square into volume. What is volume? Volume is A into L. Okay, so this comes out to be b square AL by 4 mu naught. So the fourth option is the correct option that we are getting. Next, two identical objects are placed in front of a convex mirror and concave mirror having same radius of curvature 12 centimeter. At at the same distance 18 centimeter from the respective mirror. We have been given a convex mirror. Same object is placed at a distance of 18 centimeter. It has a radius of curvature of 12, so that means 6 centimeter is the focal length. So plus 6, and in another case you have been given a concave mirror. At the same distance, the same object is placed. So it would have again the same radius of curvature, so this would be minus 6 centimeter. Okay, the ratio of the size of the image formed by a convex mirror to that of concave mirror. So first of all, the magnification, the ratio magnification, we already know that it is equal to f by f minus u for mirrors. So, and this is nothing but it is equal to image height by object height. Since these two are identical object, let the object height be h. So image height would be equal to h times of f by f minus u. Okay, so image height of this divided by image height of this, that you need to find out. So image height first, let the convex mirror have image as hi, so it would be equal to h. The focal length of the first, let it be f1 and let this be f2. So f1 by f1 minus u. For second it would be divided by I2 would be h f2 by f2 minus u. Okay, hi, this will gonna cancel out. So we'll be putting the value of f1 is, for convex it is 6 minus of minus 18, minus plus, so this would be 18. Okay, f2 is minus 6 minus plus 18, and f2 is minus 6. Okay, 6 we're going to cancel out here. It would be 18 minus 6, which is plus 12, and this would be 24. It comes out to be half. Okay, the final answer is half. Next, a sinusoidal wave of wavelength 7.5 centimeter travels a distance of 1.2 centimeter along the x-axis in 0.3 seconds. So that means the wave is traveling along x-axis. Okay, x-axis, and the crest P is at x is equal to 0, at t is equal to 0. So that means you have been given a sinusoidal wave at x is equal to 0 and t is equal to 0. It would have a crest P. So this is crest P, and this would be the wave then, and it is moving along x-axis. Okay, and maximum displacement of the wave is 2 centimeter. So that means this distance is 2 centimeter. So remember, since at x is equal to 0, t is equal to 0, it has a displacement, it has a crest at this particular point. That means the displacement is maximum. Okay, so at t is equal to 0 and x is equal to 0, you can easily put, this is the equation for sine, this is the equation for cosine wave. Okay, where at x is equal to 0, it won't be this, because at x is equal to 0 and t is equal to 0, this value will be sine 0 would be equal to 0. So y is not coming out to be 2. So this can't be true. So either this one or this one would be true. Now next, we can easily calculate the wave number, which is k is equal to 1 upon 2 pi by lambda, and lambda from wavelength is already given to you as 7.5 centimeter. Again, if you have to convert it into meter, and the final answer that we are getting is, from this you'll be getting at it is as 0.83. Okay, so from this which option is correct? So that means your first option is the correct option that we are getting. Okay, next, in a moving coil galvanometer, two moving coil M1 and M2 have the following parameters. Assuming the torsion constant of the spring are same for both the coil, which what will the ratio of voltage sensitivity of M1 to what will be the voltage sensitivity ratio of M1 and M2 galvanometer. We already know that Bina, which is your torque, is equivalent to K theta, where K is your torsion constant, theta is the angle through which it has rotated, the spring has rotated. Okay, so this where I is current, B is magnetic field, and N is number of turn, and A is area. So this I by this theta by I is your current sensitivity. So theta by I comes out to be NBA by K. Voltage sensitivity is given by theta by V, where theta is V is IR. Okay, so theta by I is nothing but your NBA by KR. So this is your voltage sensitivity. We're gonna take the ratio of the voltage sensitivity of first to the voltage sensitivity of second. So what would it would be? It would be equivalent to N1 B1 A1 divided by, since they have both have same torsion constant K, so we'll be write it as K, and this is R1 divided by again for N2 B2 A2 by K R2. So the ratio of these two would be this. K will gonna cancel out. We already have the ratios. We already have the values R1, N1, A1, B1. Put the values. Eventually you will get the final answer as 1. Okay. So this would be 1 ratio 1. Next, identify the characteristics of an adiabatic process in the monatomic gas. In the adiabatic process, the energy we already know that in adiabatic process, energy supplied is, the heat supplied is 0. So this would be at the cost of, so work done would be at the cost of change in internal energy, negative of the change in internal energy. Okay, so this is your thermodynamic first law. So work done would be minus of delta U. Now the internal energy, it says the internal energy is constant. With increase in temperature, the internal energy can't be constant. So that means this can't be true. Work done in the process is equal to the change in internal energy. Yes, work done is equal to negative of the change in internal energy. Although this has to be wrong, but given the fact, after seeing the option, I'll let you know which option could be the best possible option that you can correct. The product of the temperature and the volume is constant. The product of temperature and volume. We already know that temperature into volume is gamma minus 1 remains constant. Okay. So this is not product of temperature into volume. So this would be equal to V gamma minus 1 remains constant. Now, product of pressure. So this means this is wrong. The product of pressure into volume. P into V gamma remains constant, not P into V. So this is also not true. The work done to change the temperature from T1 to T2 is proportional to T1, T2. The work done is given by, is already given by NR T1 minus T2 divided by gamma minus 1. Again, it can be proportional to T2 minus T1. That means it would be equivalent to, if it is negative, so here it will go NR T2 minus T1 1 minus gamma. Then we can say that it is proportional to this. So this can be true, and so that means E can be true. From here, rest other can't be true, and the only possible option that we are getting is B can also be true. So second is the only option that you should remember, or you should tick, because this is the best possible answer there, because rest other parameters are, rest other statements are untrue. Next, assume the validity of Bohr atomic model of for hydrogen like ions. The radius of Li plus plus ion in its ground state is given by this. What is the value of x? Where A0 is the first Bohr orbit. The orbit, the nth orbit radius can be written as A is equal to A0, which is the first orbit radius, n square by z. Okay, so this is the relationship that we already know, where A naught is in 0.53 angstrom. Okay, so A comes out to be A naught for lithium plus ion in its ground state. For ground state, n would be equivalent to 1 whole square, and for lithium, this z comes out with the atomic number is 3. So it is A naught by 3. So A naught by x, so x comes out to be 3. Okay, so the third option is the correct option that you should remember. Next, a wheel of radius 0.2 meter rotate freely about its center when the string what is wrapped over it rim is pulled by a force of 10 Newton as shown in the figure. So that means you are pulling it and it rotates. Okay, the established torque produced on an angular acceleration of 2 radian per second square. Okay, so the moment of inertia of the wheel is, so let the radius be r. Now the moment of inertia that we need to find out, the torque would be r cross 10. Okay, radius is also this would be the torque. This torque must be equal to I alpha. Alpha is the angular acceleration. Radius is already given to you as 0.2, which is 2 by 10 into 10. Let moment of inertia is of rotating wheel is I, and angular acceleration is 2. So it comes out to be 1. Okay, the final answer that we are getting is 1. Next, the length of the light string is 1.4 meter when the tension in it is 5 Newton. If the tension increase to 7 Newton, the length of the string is 1.56. The original length of the string is, let the original length of the string is L. Okay, that you need to find out. When the tension in the string is, let the original length be L. When the tension in the string is, when the force is 5 Newton, this length comes out to be 1.4. Okay, so Young's modulus that we already know is force per unit area 5 by A. Let area be A is del L by L. Change in length is 1.4 minus L by this is original length. Okay, in second condition, the length comes out to be 1.56 meter when this tension in the string is 7 Newton. Again, the Young's modulus of these two would be same, and the area would also be same. So it would be equal to force per unit area 7 by A, and original length, change in length would be 1.56 minus L by original length is L. So we're gonna equate it. A will gonna cancel out, L will gonna cancel out. You get 5 into 1.56 minus L is equal to 7 into 1.4 in minus L. Solve it, we'll get a length value as 1 meter. Okay, it will come out to be again 1 meter. So after solving it, you will get this as this value. Next, the internal energy of the air is in this much of size of room at 1 atm will be. Consider it as an diatomic molecules. The internal energy that we already know is given by N CVT. Okay, and CV is FR by 2. It can be written as FR by 2, where F is the degree of freedom, R is gas constant, and CV is your molar heat capacity at constant volume. So this could be written as F by 2 nRT. This could also be written as, where nRT is PV. Okay, degree of freedom for diatomic is 5 by 2, and the pressure is 1 atm. Okay, so 1 atm is 1.012 into 10 to the power 5 atm, and volume is 4 into 4 into 3. So you'll get as 2. So this would be 4 3 is 12, 12 to the 24, 24 into 5 into 10 raised to power In the terms of 6, you need to calculate 5 to the 10. So this would be 10 raised to power 6. So this would be 4 to the 12. 12 into 10 raised to power 6. So the answer that we are getting is 12. Next, a ray of light suffers a minimum deviation when incident of a prism having an angle of a prism at 60 degree. So a ray suffers minimum deviation only when this refracted ray would be parallel to the base. Okay, and then it will go just like this. So this angle of deviation would be minimum when this ray is parallel. It can only happen when angle of refraction R1 and R2 would be equal in this particular case, and this is angle of a prism. This would be equal to A by 2. Okay, angle of a prism is already given to you as 60 degree, 62 by 2. So R1 comes out to be 30 degree. Okay, you need to find out this angle of incidence. So we're gonna apply the Snell's law over here. It is 1 times of sine I, where refractive index of air is 1. Refractive index of this medium is root 2. Glass is root 2 times of sine R, whereas R1 is 30 degree. Okay, half, which is nothing but 1 by root 2. So I comes out to be 45 degree. Okay, so it is 45. Next, a satellite of mass 1000 kg is launched to revolve around the Earth in an orbit at a height of 270 kilometer from the Earth's surface. Kinetic energy of the satellite in that orbit is mass of Earth is given to you, and radius of Earth is also given to you, which is 6400. It is equivalent to 6400 kilometer. Okay, radius and height is also given to you as 270 kilometers. At this height, what would be the kinetic energy of the satellite, which is revolving around the Earth? So the distance from the center, this orbital radius small r, is r plus h. R is 6400 kilometer plus 270 kilometer. Okay, so we already know the radius, and the velocity with which it moves, that we already know, is orbital velocity is given by root gm by r, orbital radius, where m is the mass of this heavenly mass along which this satellite is revolving, and small r is the orbital radius that we already know. From this, the kinetic energy can easily be calculated as half m. Mass of the satellite is small m into v square. This is gm by r. Okay, so this would be m g capital M small m by 2r. This value is already given to you, gravitational constant. Mass of the satellite is also given to you, is 1000 kg, and mass of Earth is 6 into 10 to the 24 kg, and this orbital radius is the sum of these two, converted it into meter and solve it. Eventually you will get this option as 3 into 10 raised to power 10. Okay, so the answer would be 3. Okay, I hope all the questions that we have discussed is understood to you. Stay tuned for further videos. Thank you.